Hello everyone, it's Mike here, and this is a video to let you know about a project I've been working on. It's probably what all of my time is going to go into, so I won't be on this channel much anymore. But now, I have a new channel, and I'll be over there. So, it's not the same as this channel, which is why I didn't just continue using this one. It's not gaming. I'm building a retro computer. And, well, I'm just going to play the first episode right now here on this channel. And if you like it, a link will be down in the description. You can head over there and subscribe. If you don't, I might put some more videos on here kind of when I get bored with the project. But otherwise, I'll be gone off of here. Which isn't too surprising. I've been gone for a while. So, yeah, here's the video. Hello. Welcome to Back to Basics Computing, where I will program a computer from the ground up, starting with switches and buttons, all the way up to an operating system, and possibly even beyond. When I say from the ground up, I am only allowing myself to program directly on the computer I have built. This means at the start, I will only be using my front panel to enter code, and the only text editors, assemblers, and compilers must run on the computer itself. There will be a few exceptions to this. I will be using a text editor on my PC when designing the code at the start instead of pen and paper. I'm just doing this so that you don't have to suffer through my terrible handwriting. I will also allow myself to transfer C code if I ever get a POSIX operating system with a C compiler up and running. But that code must still be compiled on the computer. So that's the challenge. But what about the hardware? I have wanted a retro computer to mess with for a while, so I decided to design and build my own. I have created a 16-bit breadboard computer using a 65C816 just to get started with. The reason I didn't record this is that it was mostly me pacing and cutting wire, so not terribly interesting. The brief technical specifications of the board are as follows. It has, as I said, a 65C816 16-bit processor, which has a max 14 MHz factory clock rate, though the maximum I'm able to get on the breadboard is 5 MHz, and it may have to go even slower as more hardware is added. It has 64 kilobytes of static RAM and 32K of EEPROM. It has 1 megabyte of something similar to cache, and it also has an LCD text screen and 320 by 240 16-bit color screen directly on the bus. There's a hardware SPI running at up to 10 megahertz on the breadboard, though on a PCB it could get up to 20 or 40 megahertz with 2 megabytes of static RAM, 256 kilobytes of EEPROM, an SD card, a WIZnet W5500 Ethernet controller. Soon it'll have a UART, and there's still room for more SPI devices. It also has a 65C22 VIA chip connected to a keyboard, so there is keyboard input. So, that will be it for this introduction video. In the next few videos, I will be going over each piece of hardware in more depth. I will also be streaming all the programming, so feel free to come hang out or ask questions. I will be doing it both here on YouTube and Twitch, at least to start out. And on Twitch, it is the same BTB computing, but no space. I will be trying to do it consistently every Friday, starting at 2 p.m. Pacific, and then just at random other days during the week. So, I hope we will all have a great time on this adventure, and leave a comment, or subscribe for more. Until next time. Well, does it sound like your cup of tea? If not, don't worry about it. If it is, again, links down in the description. And until next time, I will see you all later. Bye bye.